going to be Mr. Mike Lee. Mr. Lee is the Strategic Business Development Manager with Agilent Technologies. Mike is a Strategic Business Development Manager leading the Smart Connected Lab initiatives at Agilent. Mike has a robust background in business development, strategy, and systems architecture, primarily focused on industrial Internet of Things. Applications with significant experience in mission-critical, highly regulated systems and cybersecurity across a variety of market segments. Mr. Lee's presentation is titled The Push for Change and Change Management. Please welcome Mr. Lee to the podium.
Hi, so again, my name again is Mike. I'm here from Agilent Technologies. And as you mentioned, I have a very robust in mission-critical systems and background in industrial Internet of Things. I actually just joined Agilent about a year and a half ago, and I spent a majority of my career, about 16, 17 years at the Intel Corporation, where I was responsible for developing strategy and business development in cybersecurity systems and what was previously called embedded systems, which is another fancy way of saying purpose-built computer systems. That eventually became to be known as Internet of Things, and prior to Intel, I worked in aerospace. So I've worked in mission-critical systems, Internet of Things for a majority of my career. I have spent some time working in enterprise and consumer systems, so I do know some things about those. But in my joining Agilent, really the premise of that was to bring some of the digital experience and some of the industry best practices employed in different segments and different markets and different use cases, and begin to apply that towards our solutions in the laboratory space, both in life sciences, genomics, and pathology. And so my presentation today is really going to focus in three different areas. Really what I want to do is convey to you some of the broader industry trends in terms of digital transformation and digital technologies, kind of give you a backstory into how we got to where we are today, and then to use some different use cases in those different areas and see how we can apply those to a lab environment and get a better roadmap of how those technologies may impact the laboratory going forward. And I'm sure some of these things might be in place today, but also give you a little bit of an indication about how they're going to affect things going forward. And I think more importantly, to begin to provide you a framework about how we can begin to cut those things up into bite-sized pieces so that we can manage risk and ensure the success of our lab. I think one of the key things that I learned stepping into this role at Agilent was, in the Intel space and in Silicon Valley, people like to talk about digital disruption, and I know a lot of people don't want to have their labs disrupted, so we talk about managed change and evolution and things of those nature, and I really latch on to that, having had experience in mission-critical systems for a long time, but it's always interesting, learning different nomenclature and vocabulary. So this slide really sets the stage to bring us forward to where we are right now, which is what most people are calling the fourth industrial revolution. So if you look at the first two iterations of the industrial revolution, really we're talking about mechanizing processes that were labor-intensive, repetitive, and then eventually trying to scale those processes so that we could have higher quality, higher efficiency, better throughput, and hopefully better quality products at the end of the day. We really started to step into the third industrial revolution probably around the end of the 50s, beginning of the 60s, and the hallmarks of that for me and for the sake of this conversation really center around the advent of robotics and programmable logic controllers. And so those two things work hand in hand together. And so programmable logic controllers control the robotics, and the robotics are built in such a way that they can be repurposed for different things as your manufacturing processes, as other things evolve throughout throughout the business's evolution. Key characteristics of those systems are that they are deterministic in behavior, meaning that whatever environment they're in, they get input coming in, whether it's digital input or maybe environmental input. And whatever they do, you can determine the behavior of those systems. That's different than our consumer systems where we employ things like branch prediction, hyper-threading, parallel processes and things of that nature, where sometimes for the sake of speed, we get things that don't necessarily produce the same outputs given the same input. So you take these configurable systems that we started to make back in the third industrial revolution, and then you begin to connect them together such that they operate more seamlessly together. And so in the context of maybe a process control environment for maybe chemical and energy, or maybe for a standard manufacturing line, which maybe produces cars or widgets of some sort, you're able then to get these different collection of systems to work together more cohesively, such that they work together faster and you get better output at the end of the day. And so that brings us into the fourth industrial revolution, where everything's connected, you have more sensors, you're able to maybe look at quality aspects of things, maybe through optical sensors, different things like that. But really the connectivity is the backbone of the fourth industrial revolution. An interesting side note, the fourth industrial revolution in Europe was really coined Industry 4.0. That came out of a German initiative to maintain manufacturing excellence within that region, and has really been adopted, I think, worldwide at this point, but that's originated about 10 years ago. The other term that you hear tossed around is Internet of Things, and I think that's the other side of the same coin, where maybe Industry 4.0 is talking about maintaining excellence, whereas IoT is really talking about, okay, how do we build new business models? How do we capitalize on some of these technologies that we have available to us? But with new technologies come challenges. Let's see if this will build out. Oh, there we go. So I'll just get these all up here really quick. So the challenges that face adopting these digital type of technologies are increasing levels of integration, evolving privacy and security concerns, evolving workforce skill set, and legacy systems and standardization. And so, to me, some of those things are self-evident. When you start having more systems that need to connect together, you're going to have increasing complexity. I think we all are very familiar with privacy and security concerns from our own private aspect, but from a commercial and an industrial side of things, those tend to be even more a focus of things. And then the evolving workforce and other aspects, those are all things that really lead to some headwinds that we have in trying to get these systems adopted and successful once they're deployed. So the next three slides I want to talk about system intelligence, connectivity, and security. And so if I use the three examples that are here for the integrated intelligence slide, Plug and Play is an initiative that was teed off by Microsoft back in the early 90s. I think it was Windows 95 that was their first iteration where they came out with. But one of the things, if you look down at the bottom left of that logo, you can kind of see the little Windows insignia. What Windows tries to do with that program is to make sure that you have the best user experience possible. And so they have a set of requirements, they have hardware testing labs so that different partners can create different devices, whether it's a USB device or a printer or whatever, that can connect to their system, and you're going to get the best possible user experience that you can. We've moved a long way in the consumer field from plugging in a printer and having to download a driver or have a DVD where we have to upload a bunch of things and go through install wizards, where things just plug in and they work up and they just work. And we have that same notion in the industrial and commercial space where we talk about plug and produce. In pharma, they call it plug in something else, I'm going to forget it. But there's notions about the same type of user experience and seamless integration for the systems that we're developing today. Predictive insights, this is where we're able to get more data from different resources, so we can either get real time from data that's happening within the system itself, or maybe we're able to grab different data from other places. So within the lab, maybe we can grab temperature, we might be able to grab humidity. I know if you're talking about maybe transportation, you can tap into weather information, you can tap into bus schedules. There's a wealth of different information available for a lot of different industries. And so if we're able to take that information and do different analysis on it, we can accomplish things such as predictive maintenance, better asset management and utilization, and deliver more value within those systems. Automated actions, I think typically when people think of automation, they think of robots, but really there's two aspects to this. There's physical automation, and then there's also data automation. So physical automation is the ability to mechanize something that's a physical process. We're starting to see more and more of that within the context of the lab itself with auto samplers and some things like that, and I expect that trend to continue. But I think more importantly is automating the data flow through the lab itself to make sure that we can eliminate manual processes as much as possible and get data to flow seamlessly from one endpoint to another without human intervention. The more that we can eliminate human intervention, the more we raise our likelihood for improving data quality. So once we have system intelligence, we need that connectivity. And really, like I said in the slide 2 slides ago, was that connectivity really becomes the backbone for where we want to be with Industry 4.0 and these modern digital systems. So the example that I give here is tracking and logistics. I think a lot of us here probably took the plane here. I've been surprised to see in the last couple of years that now with most major airlines, you can look on the little app that they have for you, and you can see that your luggage has either been scanned in at the gate, it's sitting on the plane hopefully with you, it's arrived at your destination, it'll tell you the carousel that it's landing at. So they're already employing logistics like that within other verticals outside of just UPS, Amazon, and things like that. And I think if we take that example and we extend it into the lab, we can all see the value in being able to see how a sample passes through the lab and being able to scan it and have more of an automated flow as it's going through there, because again, the more we can eliminate human processes and human interactions with those things, the more likely we are to have better data quality at the end of the day. What's interesting about tracking and logistics, at least kind of going back to semantics again, it's not necessarily sample tracking or automated sample processing. We're really looking at containers and how we move that container containing the sample. Because when we talk about maybe tracking your pair of shoes that you got from Amazon or whatever, we don't talk about shoe tracking. We talk about package tracking. And so within the context of the laboratory, we're typically talking about container tracking. Remote capabilities, again, this shows a Nest, which is more of a consumer application. I happen to have one, which is fantastic. But I think one of the things that we need to be mindful of with remote capabilities is both quality of service and time sensitivity, but also privacy and security. When I mention quality of service, if you have a process that you're trying to control from outside of your organization and you do not have cell phone coverage or you don't have a good connection to that thing that you're trying to control, you may or may not have the right quality of service to be able to interact with that thing and be able to make sure that you can interact with it on a time-sensitive basis. And then privacy and security, I think one of the things that people immediately grok onto in terms of privacy and security is that you don't want to open up an external port to the outside. You don't want malicious actors to be able to tap into your organization. But once you take that laboratory interaction outside of the lab, do you only get to interact with that in a safe place? Are you able to do something at Starbucks where somebody could look over your shoulder or maybe where somebody could steal your device? So there's different aspects about remote capabilities, especially in a commercial setting, that we need to be very mindful of. Device management and extensibility. This to me is one of the holy grails for us to be successful in the laboratory environment. How do we continue to provide value to a large capital expenditure piece of equipment over time? We want to be able to continue to push down software updates. We want to be able to maybe make additional libraries, I think, available to you very easily, and so be able to really extend the value and the lifetime of that system within the context of the laboratory. On a consumer side, all of us are able to either turn our phones into a gaming device, into a thermostat control, into a texting device, and sometimes we even make calls on them. So I think we understand that concept of device extensibility over time. So last but not least, I think if you talk about connectivity and added system intelligence without talking about security, really you're talking about risk, and we all agree introducing risk into the lab is not a good thing. Security is people, practices, and products. You can have the most secure device in the world, but if you don't manage it correctly, if you don't have the right people interacting with it with the right training, you're really just introducing more risk into your organization. One of the other things that I've encountered in my prior role at Intel and working with the numerous vendors and customers that I have in the past is that there seems to be a notion that no connectivity is device security. And so I like this example. It says run for cold cold climates, cold weather. I used to live in Phoenix, so I would love to run for cold weather at some points in time. But a device like that, what happened to that is it had a default password and people are able to get on it and hack into it and put whatever message on it that they want to. In this case, it's not very malicious. But if it was a connected device, your IT could get on board, log into it, and resolve the situation, as opposed to somebody having to run out there and correct it by itself. And we have the same type of challenge within the laboratory itself. Sometimes people view a secure lab as being a lab that has no Ethernet connections, no internet connections, and that just simply isn't the case. It does take diligence and a skilled IT department and management of those systems, but again, zero connectivity does not equal security. Lastly, data privacy, very similar to security, is architecture, legal, and compliance. Architecture meaning that it's architected for a certain degree of security and data privacy. Legal meaning you need to read the legal documentation and license agreements that go with that. On a commercial side, your legal teams are almost always involved in those type of reviews. And then compliance. What kind of evidence is it giving you to make sure that you know that those systems are providing the security and the privacy that they're supposed to deliver? So this is my wrap-up of the previous section. When I talk about a digital lab, I really talk about one that's smart, connected, and secure. And so for a system to be smart, really what we're trying to do is take more intelligence, put it into the system, but we want to do it in a way where it makes the solution easier to integrate, more intuitive to use, and reduce complexity. If you have a smart system and you've integrated that intelligence and it becomes more complex and cumbersome to use, you've really missed the mark on that. A connected system, so again, that's the backbone of what it is we're trying to do in digital. It allows you to have better usability of the system, get data from other places, send data to other places, so it really helps you add more context to your laboratory. And again, security to me is really foundational to any of these things. Without security and data privacy, you really can't talk with any merit about a smart or connected system or a digital laboratory in general. And really where I think most industries have gone, or where they're going right now, is developing a platform of solutions that work cohesively together. And so, once we can have these technologies working together well in an environment where they're optimized and we've achieved the intelligence and the connectivity and the usability that we want, having a platform of solutions really allows us to build upon those, much like we have with our personal computers and our smartphones and other devices. It really allows us to innovate on top of those platforms and worry less about the underlying technology. From an Agilent perspective, we're a very unique company that we both deliver instruments, consumables, software, and services to market, and those four ingredients work together to deliver workflow solutions. But even as we talk about delivering our capabilities within a digital lab, we also have our own digital transformations within Agilent. We're trying to improve our customer experience with our customers in terms of digital capabilities and the way that they interact with Agilent. And even internally, operationally, we continue to evolve our digital capabilities. So I guess what I'm trying to tell you with this slide, we are putting things in place to become a better workflow solution company, but at the same time, I think all of us together, Agilent included, we're all kind of going through this digital transformation, and it doesn't stop. It's a business evolution and it's a business transformation. We're just happening to put digital tools in place to help us accomplish that. So these really talk about some of the key pain points that we see from our customers and across the industry, whether it's in forensics or whether it's in food, chemical, and energy, pharma, what have you. Typically, businesses are always trying to drive towards being as efficient as possible. They want to eliminate downtime from their lab, and they want to make sure that their workforce continues to develop as their lab environments develop. The other thing that we see is always improving data quality and tracking, and so we talked a little bit about that, but eliminating human error from the data that moves through your systems. Sustainability goals, do you have energy efforts that you're trying to accomplish in terms of energy reduction, maybe materials reduction within your laboratory. And lastly, increased integration into your larger business and supply chain. While this may not be completely intuitive to forensics and criminal sciences, if you look at more time-sensitive things like manufacturing and where you have batch control, maybe they've manufactured a batch of the next medicine and they have to take that out to QA and get it sampled and then send it back, you might be talking about a process that might take hours, if not maybe a day in span. And really what people are trying to do is integrate the laboratory function more closer to their time-sensitive operations such that they can get that data and do things more in real time in a continuous fashion. And I think probably with forensics and from the things that I've heard before, trying to get those answers as quickly as possible. I know in some cases we're trying to move some of the lab equipment out of the lab and more outside. Having those things more integrated into the areas where we're trying to provide the insights and the answers, that continues to be a focus for the labs that we work in. So talking a little bit about frameworks here, and I'll hurry up here because I only got a minute or two left. One of the previous presenters talked a little bit about building your vision. To me, this is one of the most important steps that you can go through as an organization. Understand where it is that you're trying to go to and really get buy-in and commitment to that vision. It sounds a little airy-fairy, but going through building a good vision statement is often going to scrape some skin off your knuckles and make a lot of friends in the process. But once you have that vision in place, that allows you to map your opportunities. You then need to assess your capabilities. What kind of skill sets do you have? What kind of technologies do you currently have? And what kind of people should you be working with to try to solve some of the things that you've established in your vision? And then finally, with prioritized execution, being able to prototype, put something out there to accomplish your vision and put in the right key metrics to be able to understand what your progress is and continuously learn over time. This is more of a summary of the last couple of slides. I think the third point is really one of the more important ones that I like to stress, is being able to reach out to other areas of your organization to build new and necessary relationships. So whether we're talking about trying to manage energy goals, you might have to work with your facilities. If you're integrating different systems that reach outside of your laboratory, or you've integrated new software, we have to have legal review, we have to have greater contact with your IT department. It's important to be able to prepare yourself to have those conversations and understand what you'll need to do in terms of engaging with other areas of your organization. So I'll just build this out really quick. So in terms of applying that towards a today, tomorrow, and the future type of horizon, when we look at this, the opportunities in front of us today are more incremental exercises. So what kind of training and services can we maybe put in place, additional software to complement our existing operations? If you look at tomorrow horizon, it's more of a capital expenditure type of high CapEx type of investment, where maybe you're investing in more informatics and you're integrating those more tightly into your business processes. So again, that requires a little bit more heavy lifting. Into the future, and I just want to be cautious about saying I'm not providing any forward-looking statements on behalf of Agilent, but maybe some industry trends. Access, no matter what kind of technologies you put in place, you really want to have better access to those technologies. So whether you're talking about better UI layout so it's more intuitive to use, or maybe voice or gesture control, better access to those solutions. Analytics is going to continue to improve over time and provide more insights. And again, automation, both physical and data automation, are really going to provide some great value within the scope of the laboratory. So lastly, digital transformation doesn't mean digital disruption. I think we can all rest better knowing that. Using a transformation framework will enable us to dissect the problems a little bit better. And again, you'll probably work across your organization, if not across your supply chain and your partner ecosystem, to accomplish some of these things. And lastly, one of the great things about Agilent is that we have a core of quality and trusted answers to help deliver those things. It's our people, it's our products, it's our services, and developing those partnerships to help deliver your digital capabilities is, I think, where Agilent has a very strong suit. So my apologies for running over, and that is it.